Hello everyone. In today's video, we're going to create a React application that has infinite scrolling built into it, and we're going to actually use quite a few interesting features of React, such as refs, and creating our own custom hooks. It's going to be a ton of fun, so let's get started now. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you. So if that sounds interesting, make sure you subscribe to my channel for more videos just like this one. And to get started, on the left-hand side, I have Visual Studio Code open, and all I did was run npx create React app with a period, and this generated all of the boilerplate React code that we're going to need. I then went around and removed all the files we don't need, such as CSS files and such as service workers and test files, so that we're just left with our index.js and an empty app file to actually put all of our React code inside of. Also, on the right, I have the finished version of our application. All we do is search here for some form of book that we want. This is going to query a book API. So we can type in test, for example, and you can see we get a bunch of different results. And when we get to the bottom of the page, you see it says loading right there, and then it'll load in our results. And we can just continually scroll down until we get to the very end of all of our results. This will just infinitely scroll until there's no more books with the name test inside of their title. Also, something this will do is if we scroll all the way back to the top and do a different search, for example, if we search for TE, you see it'll reset our pagination so that we start all over with our infinite scroll again from the beginning, and it'll clear out all of our old search results for us. So in order to get started, let's actually just create the basic JSX template for our application, and we can do that inside of our app here. The first thing that we're going to have is we're going to have an input component. So let's create an input. This is going to be a type of text, and this is actually going to be here, this input right here. After that, we're going to return some other stuff. So let's put this inside of fragments so we can return multiple sets of HTML inside of our JSX. There we go. In here is where we're going to put our books. They're going to be in a div, and then we're just going to have the title. Let's just copy that down a couple times so that we have an example of what this is going to look like. And then lastly, we're going to have a div, which is going to contain loading for when we're loading. And if we have an error, we're going to have a div, which is going to contain error. So let's save that and actually start our application. Just run npm run start. And if we let that run for just a little bit, you see it's going to start up over on the side here. And there you go. You can see that we have our boilerplate HTML being generated for us. And now we can actually work on implementing the API and infinite scrolling inside of our application. And to do that, we're going to use Axios to call our API. So let's install Axios by typing in npm I followed by Axios. And this will install the library Axios for us, which works a lot like the fetch library does, but it's much easier to use rather than fetch, which can be a bit difficult to use and isn't supported in all browsers. Now that we have that done, we could do all of our code inside of our app for rendering our books, actually querying them using Axios, and doing all that other stuff. But with React and hooks, it's a lot easier to break out our logic into a custom hook. So we're going to create a custom hook called useBookSearch.js. And inside of here, we're going to create a functional component. And if you have the extension installed, which is called ES7 React Redux GraphQL blah 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 snippets, you can just type RFC and hit enter, and it'll generate all the boilerplate code for you for a function component in React, which is also the same boilerplate code for actually generating a custom hook. We can just remove the JSX because we're not actually going to return JSX, and we also no longer need to import React, but we do want to import useEffect, just like that, which is going to be the hook that we're going to be using inside of our custom hook because we want to call our API, and that's a side effect that we want to call every single time some parameters change. We also want to make sure that we have the useState hook because we're going to be storing state inside of this custom hook, which we then expose outside of this custom hook by returning it down here in this return. For now, we'll just return null. And inside of this component, what we need to do is query that API like I mentioned, but we need to take in a few parameters for what we're querying. The first thing we want to take in is the query. Essentially, whatever we type into this text box here, we want to send to our search. We also want to send in here what page number we're on, because while we are doing infinite scrolling, the way that infinite scrolling works is as soon as you get to the bottom of your list of results, it'll query the next page of results from the API and append it onto the bottom of our page. So we need to know what page number we're currently trying to get from the API. And once we have those two pieces of information, we can actually set up Axios inside of an effect. So we can just say here, useEffect, and this is going to take a function, which is what we're going to do every single time that the parameters inside of this array, which is the second argument to useEffect, change. And in our case, we want this to happen every time our query or our page number change. And inside of here, we can use Axios to get our information. Let's first import Axios from Axios. And we just want to say Axios, and this is just a function which is going to take all the parameters that we need to give it. So for example, a method, this is going to be a GET request. We also need to give it a URL. I'm just going to copy this URL from the API we're using. Essentially, this is the Open Library API, and we're using the Search API that they have built in, which has pagination built into it. So we can pass that as our params. So the first thing is our query, and in this case, they call that param Q in the API. So we're going to pass Q as query, and we also need to pass page, which is just our page number variable. And these are things you can find in the API documentation for this API, but for our example, Q is our query, and page is the page number that we're on inside of our query. Also, with Axios, this is going to be a promise-based thing, so we can just use .then, and this first .then here is going to return us our response. So we have our response variable, and then we can actually do something with that response. And the data of our response is inside of res.data. And this data, we can just console.log this for now, and we'll take a look at what this looks like so that we can actually understand what our data is doing. So now back inside of our app, let's import that hook. So we can say import use book search. We want to import that from our /use book search. So now we actually have this hook inside of our application, and we can actually use this hook. For example, we want to pass it our query, and we want to pass it our page number, which right now we don't have stored anywhere. So we need to store these inside of state. So up here, we can just import that useState hook, which will allow us to create some state. And the first thing we can do is set up state for our query. So we have query and set query, and we're going to set this here equal to useState. And by default, our query is just going to be an empty string. And this useState function returns a query as well as a function to set that query, which is going to re-render our application. Let's copy this down and do the same thing for our page number, as well as for setting our page number. And by default, we're just going to have page number 1 for when we load our application. Now we actually have these variables being set, but we're not updating them anywhere. The easy one to update is our query, so we can just update that in our input. We can set an onChange event to this, and we can just say in here we want to call a function called handle search. And we can create that function just like this. So we'll say handle search, and this is going to take the event, and then it's going to actually do some stuff with that event, which is going to be setting our query. So we can say set query, and we want to set that to e.target.value, and this is just going to be the value of whatever is in this search box. We also want to set our page number back to 1, because every time we query, we want our data results to start at the very first page. We don't want them to start at page 7 if we do a new query. Now that that's all done, let's actually save this, inspect our page over here, and make sure this is working as we expect. If we go into the console, zoom this in a little bit, you can see that we first are getting an object for our blank result, but if we query test, we should here, you see, get a bunch of results, and this is because we're not canceling our previous request. So every character that we type is actually sending off a request, because every character we type causes this function to run, which updates our query, which then updates our search. So we're going to fix that in a little bit. But what I do want to look at is the actual results we get returned. As you can see, this data has a docs field, which is all of the different books that we are querying. You can see it's a very long list. And inside of here, we also have the number of results found, as well as the start. So this is what page we're currently on. So for example, start 0 is page 1. And then whatever our pagination number is, which in this case I think is 100, so start 100 would be page number 2. And this num found is going to be really useful for when we know when to end our infinite scrolling. But to get started, let's worry about this cancellation, because we don't want to send a query every single time. We want to cancel our old query if we are typing information. So in our use book search here, Axios has a really easy way to set up cancellations. It takes a parameter called cancel token, and this cancel token is equal to Axios.cancel token. And we want to create a new one of these. And this is actually capital cancel here. And inside of this cancel token, it's just going to take a function, and this function takes a single parameter, which is going to be the cancel token. And we want to set our own variable to that. So let's create a variable called cancel. And now we're going to be setting that variable cancel here to this C from our cancel token. Essentially, this is allowing us to cancel our request. And what we can do inside of useEffect is if you return something from useEffect, you return a function, and then inside that function, we can just call cancel, and this is going to cancel our request every single time it recalls a useEffect. So now let's save that, and we can start typing inside of here, and you can see that immediately we're getting uncaught promises because every single time that we cancel something, it causes an error to occur inside of our promise. So let's actually catch that. We can say inside of here, we want to catch our error. And what we want to do is we want to check to see if this is an Axios cancellation error. So luckily inside of Axios, they have built in a really easy way to say is cancel. We just pass it our error. And if so, we just want to return. Essentially, we're saying ignore every single time that we cancel the request because we meant to cancel it. Now, if we save that and go over here and start typing, you'll see that only one request is made. No matter how many characters we type, it's only going to send that one single request, and it's not going to send a bunch of extra requests because it's actually canceling those for us, which is really great. Also, inside of this catch, we can return any errors we get so that we can actually notify the user of errors. So now it starts setting up the state inside of our use book search so we can return this because right now this does nothing. It's just returning null and logging to the console, but we actually want to return data to our user from this. So we can set up our state, and we're going to have a few different things as state. The first thing we're going to have is loading. So we want a state for loading as well as a way to set loading, and we can say use state. And of course, by default, we're going to set our loading to true because the very first thing we're going to do is load inside of our application. Next, we're going to set up a error as well as set error. And by default, we're not going to have an error, so we're just going to set that to false. The last two pieces of state is we're going to have our state for our books. This is pretty self-explanatory. This is the actual books we get back from our API call. And we want this to just be an empty array to start with because we have no books being found. And then the little bit more confusing piece of state we want is a has more as well as set has more. And we're going to set this here to use state. And by default, we're just going to set that to false just in case there is no more results. And this has more essentially is telling us when we get to that num found. As you can see, there's 79,000 results. If we somehow scroll through all of those, we don't want to keep making requests to the API because there is no more results. So this will essentially prevent us from making requests that we don't really want to make. Now that we have all of our state set up, let's actually start setting the state inside of our application. So the first thing we want to do is every time we make a request, we want to set loading to be true because we are now loading. And we want to set our error to be false because we no longer have an error because we're starting a brand new request, which hopefully will succeed instead of fail. Also, inside of our .then here, we can set our state for our books. So we can say set books, and this is actually going to be using the function version of setting state, which allows us to take the previous state, which in our case is previous books. So we can actually modify our previous books, and what we want to do is we want to return our previous books combined with our new books. So we can say previous books, and we want to spread that, as well as we want to add in here our new books, which is going to be our res.data.docs. As you can see over here, we have, if I open this up, docs, this is going to be our books. And we want to map over that because we just want the title of our books. So we're going to have a book here. We just want to get b.title because this is the title of our book and we don't care about anything else. One thing to note though, is that this actually is going to return to us a list of variables where we could have multiple titles because this data actually does things beyond just the title of the book. It actually has additions and other things. So it may have multiple titles that are exactly the same, and we want to remove those. And a really easy way to do that is what's called a set. Essentially a set in JavaScript, you can pass it an array and it's going to return just unique values. It's not going to return any of the other information. So we're going to have only the unique titles, and all we need to do is convert this back to an array by just spreading over our entire set. It's a little bit confusing, but essentially what we're doing is we're combining our old books with our new books, and then we're converting it to a set, so we remove all the duplicates, and then we're converting it back to an array, so we can do all of our normal array manipulations, such as looping and mapping that we want to do later. So now that we have our books set, let's also set our has more. And has more is going to be pretty simple. We just want to check here if the res.data.docs.length is greater than 0, which essentially means that we have no more data because there's no books returned to us, so that we know that we never need to make this query again. Also, we can set our loading here to false because we're no longer loading our data. Also, inside of our catch, we want to set our error to be true because we actually do have an error that is coming from our results. Something went wrong with our API, so we want to make sure we make note of that. And now that we have all of these different variables being set, we can actually return these to our user. So down here in our return, we can return an object, and this object is going to contain loading, it's going to contain error, books, as well as has more. So now all of the state from our hook is being returned from this hook, and we can use it inside of our app. So now here, we can say that we want a constant variable. It's going to be equal to this, and we're just going to destructure out our books, our has more. We're going to destructure out loading, as well as error. So now we have all of the different variables from our use book search that we have available inside of our application. And we can actually start rendering some of this information. For example, we can come in here and actually render out our books. So we can say books.map, so we can loop over all of our books. And for each book, what we want to do is we just want to call a function here. And this function is just going to print out a div. So we can just say return div. We need to give it a key, because in React, whenever you render a list of items from an array, you need a unique key, which in our case, we're just going to put our book in there, because these are the titles of our book. And we know they're unique since we use that set property to make sure we only returned unique books. And then we can just put the name of the book in here as well. Also, our loading, we can put in, if we are loading, then we want to put the text of loading, ... And let's just copy this down, exact same thing for error, but instead we're going to say error, and we can remove this error down here. And now if we save this, close out of this console, and we just type in test, for example, you can see it says loading, and then we get the list of all of our different books. But you will notice our books aren't quite being structured right, and that's because in our use book search, I forgot to actually spread out our results. So now if we save this and do a new search for test, you should see we're getting all of our results perfectly in here, but of course there's no pagination set up yet, but that's okay. We're going to work on that now. But there's still one bug. If we scroll back up to the top, and let's say we change our query to be just T, there we go. And now you can see that our results are actually being appended onto the end. We have all of our T results as well as our test results. So what we need to do inside of our use book search is use another effect. And this effect is going to be a very small effect. And all it's going to do is every single time that we change our query, we're going to set here our books. So we're going to say set books. We just want to set it back to an empty array. So every time we change our query, we're going to reset our book array so that we don't have any of our old books being shown up. Now if we save this, search for test, you see we get all of our test results. If we change it to T, you can see we're just going to get our T results back, which is perfect. Now with all of that out of the way, we can finally work on the part that you've been waiting for, which is setting up pagination. So if we go back to our app here, one thing that I forgot to do is set our value here, value to our query. So let's just make sure we do that. That way, just in case we change our query somewhere else, it'll be updated inside of this input field. Also, to set up pagination, we need to use what are called refs inside of React. So we can just come in here and say use, ref. And a ref is essentially a value that persists after each render. Because inside of React, every single thing that we do is only stored inside that render unless it's part of our state. But if we want to store something between renders that isn't part of our state, we need to use ref. And ref is really great when you need to store references to elements, for example, if we want to get a reference to our books element, our input element, or if you want to get a reference to something that's related to the document API. And in our case, we're using IntersectionObserver, which is part of the document API. So let's create a variable. We're just going to do it all the way up here. We're going to say const observer is going to be equal to useRef. Just like that. And by default, the first time this gets ran, it's just going to have undefined as the value, which is okay. We also need to get a reference to the very last book element, because what we're going to do is we're going to make it so that when we scroll all the way down and that our very last book element, in our case Scandinavian cooking, is shown on the screen, then we actually want to change our page number and add 1 to it. So IntersectionObserver is going to allow us to say when something's on our screen, but we need to get an element reference to that very last element in our books array in order to know which element is the last one. And you would think we could just do this with useRef, but like I mentioned, useRef is not part of our state, so it doesn't update every single time that it changes. So when our reference changes, it doesn't actually rerun our component. So what we're going to use is useCallback. And this actually has a really unique interaction with useRef, where if we set a ref, so for example, if we said ref is equal to, and we used a useRef, so if I just come up here and say const last book element ref, and I set it equal to useCallback, and I actually supplied information here, we could set that reference down here. And now what's going to happen is whenever this element is created, it's going to call the function inside of useCallback with the reference to the element that we're using down here. So it's going to call a function which is going to have node, for example, as the parameter, and this node corresponds to this individual element right here. But we only want to do this for our very last book. So let's put in a simple if check here, and we can just say that if our books.length is equal to index plus 1, and we can just use the index inside of our map like this. We can say index is the second property to map. So if, for example, our length of our books is equal to our index plus 1, essentially this is the very last book, then what we want to do is we want to return this because we want to get a reference to that very last book. Otherwise, if it's not the last book, we want to do almost the exact same thing, but we no longer need this ref anymore. So we can just return a normal div just like that. Now, if I come up here and I just want to put in something that says console.log node, so we can see that this is working. And if we save this, search for test, and if I inspect our page, you can see that that last book, which is Scandinavian cooking, is getting logged out to us. So it's calling this last book element ref every single time we render that component. Now all we have left to do is actually set up our intersection observer in here so that we know when we're on our last element. So the first thing we can do is we can say if loading. So we want to check if we are loading, then we just want to return, because if we're loading our information, we don't want to trigger our infinite scrolling, because otherwise it'll just constantly call the API while we're loading, and we definitely don't want that. So with that out of the way, the next thing we need to do is we want to check to see if we have an observer. So the way refs work is they have a variable property called current, which is whatever the current iteration of that variable is. So if we have an observer, what we want to do is we want to disconnect that observer because we're going to reconnect it. So we can say observer.current.disconnect, call that function. This is going to disconnect our observer from the previous element, so that way our new last element will be hooked up correctly. And we just make sure we check our observer because, as you remember, by default this is going to be null the very first time around. The next thing we need to do is set our current observer. So we can say observer.current is going to be equal to a new IntersectionObserver, and this is going to take in a function, and this function takes all the entries that are available, so everything that it's watching is going to be in this entries array as soon as they become visible. We're going to implement this function in just a little bit, but we want to finish out our function here by saying if we have a node, so for example, if something is actually our last element, we just want to make sure that our observer is observing it, so we can get our current observer, and we can say that we want to observe our node just like that. And just like all the other callbacks that you get with hooks, we actually need to return a list of dependencies. In our case, our dependencies are going to be loading as well as has more. These are our only two dependencies that we're going to be messing with. And now inside of this function, we can implement this. So the first thing we want to check is if entries, and we want to get our first entry because we're only ever observing one single node. So if our node that we're observing, we want to say if it's intersecting. Essentially that means it's on the page somewhere. Then we're just going to console.log visible. So we can actually see if this is working. And of course, we're getting an error. And that's just because this hook down here, which is actually getting our loading information, I need to just move this up so that it's above the code that's actually using that loading. So we'll just put it all the way at the top here. And now if we save this, that error should go away. Perfect. Now we can type in test. And you can see nothing's getting logged. But as soon as we get to the very bottom of our page and that element becomes visible, you'll see it gets logged out that it's visible, which is exactly what we want. And inside of this code, we can actually add one to our page. So we can just say set page number. Set page number. We want to get our previous page number. And all we want to do is add one to that. So we'll say previous page number plus 1, just like that. And also the last thing we need to check inside of here is if we have more. So the reason we're checking has more is if we're out of elements to query, essentially our API has queried all the data, we don't want to continually keep calling this API. So this won't allow us to keep paginating forever, because otherwise it would just paginate forever. So now let's save this and see if this works. If we type in test and we scroll all the way to the bottom of our page, you can see we get the text loading and it allows us to scroll some more and we get loading again. And if we search something that's a little bit more specific so that we can test to see if our has more works, we can say the Lord of the Rings, and now it's loading And as soon as that's done loading, we can see that we can scroll all the way down. It's loading, scroll a little bit more, loading, keep going. You can see we got loading again, and hopefully we're getting close to the end here. As you can see, that's the very end. The loading went away, and it's not trying to keep querying our API. It just completely stopped, which is exactly what we want. And that's all it takes to set up infinite scrolling with React. If you enjoyed this video, make sure to check out my other videos linked over here, and subscribe to the channel for more videos like this one. Thank you very much for watching, and have a good day.